Welcome to screencast session on week 4, finding the parent information and the level information using BFS. So the existing BFS approach only we are using, but we are using that initial setup of two different dictionaries. One is for parent information and another one for that level number. So we are using that existing queue implementation from the week 3 only, and let's implement that. So whatever the BFS algorithm is there, so few changes we do. So we do the initial setup. So in the initial setup, so we have the level information and parent information, so which it contains the two dictionaries. So these two dictionaries are initially it's empty. So once these are empty, we want to set that some initial values for it. So by default, each vertex, so that is available in our adjacency list parameter of the keys, and that keys we want to use it for the level information dictionary, that is each vertex. Initially no one have the parent information, no one have a level information, so that parent information is -1 and the level information is both of them are going to be -1. So because no one knows its level information, which level it belongs to, no one knows that who is the parent of it until we do a traversal. Now we create the object or instance of the queue class. Already queue class is available. Then we want to start that from the root vertex or whatever starting vertex you have given. So the level information of the root, which level it belongs to us. So you have given a start vertex. The start vertex is 0 because root level is always it's 0. Then q, we are adding that whatever that nq operation, we are adding that start vertex. So this is we have done for the root where you want to start that traversal. Let's do that repeating or iteration until my queue will become empty, while that not, so queue is empty. Until my queue is empty, this particular traversal will keep on going. So inside of it, the current vertex information we are getting, the current vertex is q.dq, that is getting or removing a first come first service based element, that is from the queue. Then so whatever adjacents are there, that adjacents we want to get it. So for the adjacent vertex, so inside of your adjacency list, that is the current vertex adjacents we are getting. Then if the level number we check it, so the level number of that adjacent vertex, if it belongs to that -1, so -1 means that so it's not having any level information, then simply what I do is, so the level information, that is the level of this adjacent vertex is, simply we add it whatever that current vertex, so the level information of the current vertex +1. So simply whatever that current vertex is there +1, so that if A is having adjacent of B, so B level is updated with, so A level number +1. Additionally, we are going for another level. And similar lines, we want to update that parent information of the adjacent vertex, so which you are updating that, so current vertex, so that if A is the root and B is the descendant for the A, so B's parent is going to be that current vertex, that is a because it's a root, so that simply it is updated, the parent of that B is going to be A. So once done, we are trying to add it into the queue. The adjacent vertex is added. Similar process is repeated for all of the adjacents, so which is going to be repeated until my queue will become empty. So once all done, so the final data we return the parent information and as well as the level information. So let's return the level information and parent information dictionaries. So both are the status of level data and parent data. So now we are writing the main one, the main function. So inside of the main function, we have the same graph, which is a directed graph we are using, the adjacency list of dictionary, and it is having 0th vertex is having two adjacents, 1 and 2. So first vertex is having 3 and 4 are adjacents. Second vertex is having that 4 and 3, and then third vertex is having that 1 adjacent of 4, and fourth vertex is having that no adjacents or no children. Now print that, find the parent information, and sorry, it is the function name which you have defined is that BFS. So BFS parent and child number, which is level number. We are sending that adjacency list, and as well as from where you want to start it, that is from 0. So let's run this. We want to get it the two informations. So one is the parent information and one is the level information. Of course, first it is a level information. So you can find that 0th root is having that which level it belongs to. It belongs to the level of that 0 only because it's a root. So 1 is belongs to that first level number. 2 also belongs to the first level number because the 0th node is having that two adjacents of 1 and 2. So what exactly the root 0 is having 1 and 2 adjacents, both of them belongs to that same level. When it comes to the 3 and 4, they belongs to that so level number 2 because they are next descendants for 1. Similar lines, the parent information you are getting, so 0 itself is a root, it's not having any of the root itself, so that it's a -1, no root is there. So but 1 is having the root of 0. So who is the root of the first vertex is 0. Who is the root of the second vertex is 0. Who is the root of the third and 4 is the 3 and 4 is having that root of that 1. Because of this BFS you have done it. So the root is having the common root for 3 and 4. So hope you got it. Thank you very much. Have a nice day.